Now we come to the second problem, and it's all about rhombus and square. Here also problem a bit different. Here is a rhombus, and here is a square. And it is given that the length of the rhombus, length of the sides of the rhombus and the squares are the same. So A, B, C, D be the rhombus, E, F, G, H is the square, and the length of both the rhombus and the square, they are same. And another clue is, the second clue rather, is the length of the diagonal of the square, not the rhombus. The length of the diagonal of the square is 40 root 2 square, 40 root 2 centimeter. 40 root 2 centimeter. Here is a rhombus and a square. The similarity between them is the length of the both of them are equal. And the second clue is the diagonal, length of the diagonal of the square is, here it is FH, you may draw it as G, whatever. The one of the diagonal is enough here, it is 40 root 2 centimeter. And another clue is there. The rhombus has its diagonals. The rhombus has its diagonals AC and BD, and the length of the AC and BD, the length of AC and BD are in the ratio 3:4. So, given number 1, length of rhombus and square equal. Number 1. Number 2, diagonal of square is 40 root 2 centimeter. And number 3, ratio of length of diagonals of rhombus is 3:4. I again repeat, here is a rhombus, here is a square. The first one given clue is length of rhombus and square equal, AD equal to EH, AB equal to, they are all equal because rhombus and square we both know, they both have sides equal. And in that case, both of them has their sides equal. And another clue is that this diagonal of the square, its length is given 40 root 2 centimeter. And third clue is the rhombus, the length of the rhombus, the length of the diagonal of the rhombus AC and BD, both of them are diagonals of the rhombus. Their length ratio is 3:4. Their length ratio is 3:4. So we can take 3:4 ratio. We can take BD as 3x and AC equal to 4x, or we can take BD equal to 4x or AC equal to 3x, whatever it is. But their ratio should be 3:4. So we took it as 3x:4x. And what we required to determine is area of the rhombus. This is, we have to find out. Clues are that 1, 2, 3, as I told you. Length of both of them, square and the rhombus equal. Diagonal of the square is 40√2, and ratio of length of the two diagonals of the rhombus is 3:4. We have to find out the area of the rhombus, and area of rhombus, as you know, area of rhombus equal to half into product of diagonals. So it's clear that here the two diagonals are given indirectly, their ratios are given, and we have taken it as 3x and 4x, so that if we find the value of x, then you can easily find out the length of the diagonals and easily put it on that equation and find out the area of the rhombus. But some while before, what the previous sums, in case of the previous sums, this formula was not applicable, because in those cases the diagonals were not available and there was no provision for deducting the length of them. So here we will concentrate on the diagonal, and the clues are like that. So from the second clue we can take that this is the diagonal 40√2 and this is a square. So as you know, in case of square, if you take the length as A from square EFGH √2A equal to 40√2. So A equal to 40 centimeter. I again repeat, from square EFGH, so √2A equal to 40√2, or A equal to 40 centimeter. So this is 40, 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 and all these are 40 because the length are same. So now in this case, in case of rhombus, you must know that the diagonals bisect each other at right angle. The diagonals of a rhombus, they must be unequal because it is a rhombus. The diagonals of a rhombus are always unequal and they bisect each other at right angle. They bisect each other at right angle. It's a common thing. As you know, the diagonals of a rhombus always bisect each other at right angle. So this is right angle and bisect. So if BD equal to 3x, so if we concentrate on triangle, a little triangle AOB, what we get? BO, AO, AB. The three sides are BO, AO, AB. BO 3x by 2. Okay, it's half because bisect at right angle. So BO equal to half BD equal to half into 3x equal to 3x by 2 centimeter. BO. Now what about AO? Similar thing. AC is 4x centimeter. AC is 4x centimeter because ratio was 3:4. So we took it as AC equal to 4x centimeter. So AO must be half of the AC because bisect each other, as I had told you earlier. So AO equal to half AC equal to half into 4x equal to 2x centimeter. So in this triangle we got all of the sides. AO equal to 2x centimeter, AO equal to 2x centimeter, BO equal to 3x by 2, AO equal to 2x, and AB equal to 40 because the length of the square was deducted from that blue 40 root 2 diagonal, and it was given that the both of them has same length. So here also AB is 40, AD is 40, so AB is 40. So AB equal to 40, AO equal to 2x, and so here AB equal to AB equal to 40 centimeter. So these three, and what you told that this is also a right angle triangle because both the diagonals bisect each other at right angle. In case of rhombus, you should remember, you must remember this. So here is also the Pythagoras theorem is to be applied. The same Pythagoras theorem is to be applied Pythagoras theorem from triangle AOB. This is right angle, so AB is the hypotenuse. AB square equal to BO square plus AO square. AO square plus BO square. So AO square plus BO square. So AB 40 square, AB value is 40 equal to AO. AC was 4x and AO we deducted 4x by 2, 2x. So 2x square plus BD was 3x and BO was 3x by 2. So BO square 3x by 2 whole square. So this is the equation. From this equation we will deduct the value of x and accordingly we will find out the area of the rhombus. So 9x square by 4 plus 4x square equal to 1600, 40 square. or 9x square plus 16x square equal to 1600 or 25x square समान 4 into 1600 or x square equal to 4 into 1600 by 25. That is 6400 by 25 or x equal to root over 80 by 5 equal to 16 centimeter. So from this equation, simply solving, we got x, the value of x was 16 centimeter, and we will just put it here and we will get one diagonal, and put it here, we will get the another diagonal. It is very easy now. So BD equal to 3 into 16 because x value of x was 16, 48 centimeter, and AC equal to 4x, 64 centimeter. So area of rhombus, this formula, area of rhombus, so final area of rhombus half into product of diagonals. So here are the diagonals BD and AC. So half into 48 into 64. So 24 into 64 equal to 2464. 1536 square centimeter. I think there is no confusion. I again repeat the whole sum once again. Here is a rhombus, here is a square. Both of them have equal length. It was given number clue, number one clue. Second one was the diagonal of the square was 40 root 2 centimeter, and the third clue was the diagonals of the rhombus. Length of the diagonals of the rhombus was in the ratio 3:4. So we took it as 3x and 4x, and from this clue 40 root 2, because this is a right angle, this is a square, so this is right angle, so this is hypotenuse, and this length we took it as a. So a square plus a square equal to 40 root 2 whole square, or root 2a equal to 40 root whole square. That was, we deducted the value of a, it was 40. So we put it here. The length of the rhombus was 40, 40, 40, 40, and these diagonals bisect each other at O, and so we took any one you can take, any one triangle. Here we took ABO, and the BD was 3x, so BO was 3x by 2, and AC was 4x, so AO was 4x by 2, that means 2x, because they bisect each other at right angle, and this was right angle, so hypotenuse, Pythagoras theorem we applied again, AB square equal to AO square plus BO square, and thus we got the value of X as 16, so the value of BD was 48 and value of AC was 64, and now the formula, simple formula for finding the area of rhombus, half into product of diagonals, half into 48 into 64 equal to 1536 square centimeter. That's all for today. And you have any queries, any doubt, or if you can follow my proceedings, then you please let me know it, so that I can highlight the points where you faced any difficulty. That's all for today. Thank you.